correctly. Pico RV32A. Okay. Pico RV32A, and then we'll put a tag. So just for the purpose of knowing which is the run we are doing, and just to overwrite any previous runs with the same tag, we're going to do a overwrite. Then to run it in the interactive mode in the tool environment, we'll do the interactive. Okay. So this is the command we are going to run. Same command as last time. Floatical design Pico RV32A tag, whatever tag you want to put, I've put test ACT. Do an overwrite so that you overwrite any previous tags or previous directories with the same tag. And then do an interactive. So your tool environment should boot up. So I'll wait. Which command, Prabhati, do you want me to copy paste? This flow.tickle command? I can paste that, sure. You also have this command at your end, so nice. So what we are going to do now is we are going to do the usual, what we did last time. We're going to do the run synthesis. And this time, if everything is loaded correctly in the tool environment for you, you should be able to run synthesis at your end. So please do the run synthesis command. So I'll wait for people to run the run synthesis command. Let me know whenever, please, in the Q&A session whenever your command completes. I'm hoping. So Pradyum, why have you not specified PDK root? Please specify PDK root. That's what we started with, right? Always specify PDK root. Mithul, we have provided all commands in the PDF. There is no point of providing the commands in the text file. If we provide everything in a text file and if you just run the text file, you don't learn anything. There's no point in executing scripts without understanding what those scripts are. If this course was just about executing scripts, then you don't learn anything. You just executed a script. You need to be able to create the commands yourself. You need to get to that level. It will take a while. Obviously, this course is not going to be enough to get you to that level, but it should be a starting point. You should start learning what is going on the scripts. Change the scripts for your design. That should be the aim. Learn the way to learn what is in the background of those scripts. Okay, so Surya Krishna is saying executing. Please let me know whenever this is done. Okay, for George, it was successful. Nice, very good, good. So for anyone whose synthesis is done, we'll do the init floor plan like we did last time. Please run the init floor plan command. So I'll just type the command here. Okay. So run the init floor plan command. Excellent. People are running it successfully. So please run the init floor plan command. Excellent. Now after init floor plan, what are we supposed to observe? Let me go and observe that. Okay. So after we run the init floor plan, in the runs directory, there should be a test EICT folder. In the test EICT folder, there is a temp directory. In the temp directory, there is something called floor plan. And here, as you can see, there is a file called verilog to def open road. Same file which was created, it is present. And we can just do K layout on that file and open it. And you observe that's just the outline of your design has been created. Now comes the interesting aspects. So this is what all we did till yesterday, right? We also did a PDN generation. So what I would advise everyone to do is we'll run the PDN gen script today also. But in order to catch up till yesterday's work, using this design, do the PDN generation at your end for this RISC-V core. Try all the different combinations after today's session at your end. So you'll catch up, you'll be able to practice different PDN generation strategies. The script, what exactly you have to paste has already been shared with you. So change those widths, those heights, those pitches and everything, and try to observe if you are able to see a change in the PDN generation. So do that at your end today. We'll just run the command today and proceed to the further aspects of the design. Now, before we do PDN generation, one of the things we usually do is place IO. So yesterday we skipped a step called place IO. So we want to observe how do we do the IO placement. Okay, that's one of our today's one of the 4 targets for today is this IO placement. And how do you place the IO as you would like to place. Okay, that's what the target we are going to keep. Okay, so let me first explain this in a couple of slides. Okay, let's first do a place IO command and observe what is its effect. So I'll do a place IO. Okay, and after I did a place IO, what the output which I got was it's saying yes, please everyone do a place IO. So place IO. Run this command, and what you'll observe is you'll get this. It will say random pin placement, random mode even, IO placement done, and there would be a IO placer.def which got placed in your temp directory in this directory. So as you can observe, I have a IO placer.def. Please run this and open this IO placer.def in Klayout and see what is the effect after you have done the place IO. I'll wait for 5 minutes for people to catch up and run this place IO and observe its effects. I'll open it in my site as well. So for me, I am getting something like this. I have all these IOs which have been placed at the boundary. Please try this at your end and see if you're able to get such an output. So I'll wait for 5 minutes for people to catch up to this. Okay, yes, excellent question by Umabagri. Is what is place IO basically? So it is a command which is aliased for the OpenLane tool basically. So whenever anyone creates a tool, they create a subset of commands which run some particular set of scripts in the background. So the script which place IO runs is supposed to place these IOs on the periphery of your design outline randomly. Similarly, we'll explain other command which will place in a particular pattern as we specify. So in any tool environment, there you have some commands which go and source some scripts, and those scripts do certain functions. Now, instead of this place IO command, I will later on show you that you could have run a superset of those commands. There are, and we are doing, we did commands init floor plan, place IO, PDNGen, and all those things. There is a superset of these commands. If I run flow instead of this, if I would have run floor plan, then it would have done all of this together in one command itself. So basically, all these commands are created to run in the tool environment, and they are supposed to run a set of scripts. And after this course, if what you should do as a future exploration is try to observe, understand this OpenLane environment more and more. Where do each of these commands, what are the scripts they are sourcing, so on and so forth. Okay, so can someone confirm if they are able to do the place IO command successfully? Okay, perfect. Excellent. So now what we are going to do is, I would advise you to actually exit this session. Please do exit. We will rerun this session. So exit and come to your bash, and then do not rerun right now. We want to do certain changes. Okay. This next part is very important. We want to do certain changes to your environment before we go to the further. So we'll come to this relative and absolute area parts a little bit later on. We'll come to these. But for now, what we want to do is we want to understand the difference between place IO and place IO OL. So Place IO command, which we just ran, lets us do IO placement on the design, but it all the script which does it randomly. Okay. But place IO all runs IO placement based on input configuration. So you will provide now a configuration. You'll create a configuration file, which you'll tell which pins are going where. So sometimes it is important for you to be able to tell, okay, this pin has to go in the top of the design. This pin has to go on the left of the design. So, or you might know all the possible locations of the pins. In such a case, you do place IO all and provide the location of the pins you care about. So let's see what we're saying. What we'll do is I will do this in the tool environment. I'm just trying to explain. We'll create a pin order config file and place it in the same directory as your design. And then we'll also set an environment variable, which is this. Okay, in your main config file. So we'll do these two steps one by one, and then we'll run the place IO all command. Okay, so that is our target for next today's session. This is your primary target, placing pins as you would like. So we'll do this very slowly. Okay, just showed you what is the main target. I'll give you this command, where to do what command. I'll put it in the chat box. Okay, so we'll go back to the command line. Okay, so as I said, exit this session. What we want to do is I'll tell you the location we want to be at. We want to be in the directory where you have this. So we want to be in the Pico RV32A directory. Okay. Where do we want to be? We want to be in the Pico RV32A directory. I will open another terminal for looking at the basically my source code for my Pico RV32. So let's do that. So this so my source code for Pico RV32 is Pico RV32.v. Okay, so this is my source code. I did a more on this, and I just want to find some ports. Okay, so just for the trial of my IO placement thing. Okay, so please go to this directory, your Pico RV32A directory. In this directory, we are going to create a new text file. In this Pico RV32A directory, we are going to create a new text file. So I'm going to do for here, let's do vim pin order CFG. So just try to keep the name same as I am doing for the sake of consistency. Do a pin underscore order dot config, like I'm showing here. Create a new file. Okay. I'll wait for people to catch up. In the Pico RV32A directory, create a new file called Pico RV, pin underscore order dot config. Okay, so I'm hoping everyone has created this file. So what we are going to do is now write some stuff in this file. Okay. So let's start with, I want to say put this on the north side, this on the south side, and this on the left side, and say this on the right side, something like this. First, right now I'm just picking randomly some orientations, and then we'll go along and change them as needed. So let's see. The target right now is /n. Let me change the text color. Please. It's color is quite odd in Vim. That is not. So basically, how do I change the text color? I think this will cause no one will be able to see this. So let me just open this and get it. So pin order config. So that's my file. And what I'm going to say is, let's put my clock port on the north, and please follow along as we are doing. Then we are going to have a south direction. So south, let's make it reset n. Then let's make east direction, and let's pick say the trap register output, and then let's pick the west direction. And then there is something called mem valid in the RTL. So just I'll wait for everyone to catch up. What I did was I created a pin order config, pin underscore order dot cfg. In that, what I did was I put my some pin orientations. So the clock goes on the north direction, reset in on the south direction, trap on the east direction, mem valid on the west direction. This we are just doing it first on the trial, then are we able to do this? Okay. Take your time, create this file, please, at your end. I'll give you 5 minutes to just create this file, and then we'll do the rest of the change. In Vim, you're supposed to press escape after, means you write in the insert mode. If you press I to enter the insert mode, then you type your stuff, and after typing the stuff, you press escape. You get exit from the basically the insert mode, and then you do :WQ. Okay, Naveen has a good question. He's asking, how do we know the pin directions? How do we set them? Excellent question. So Naveen, all the pin directions, let's assume that for a moment that you are creating a block inside a SOC. So how does your with respect to routing, right? What with respect to routing is, what is the pin order you care about? That is how you write the create the pin order. It has to ease up your routing basically if it is a block. And then with respect to the SOC, sorry, if it is your top level, then how do you want to create pads? Basically, how the pattern creation dictates where your pins go. So after that, what is the last signal? The last signal I've used is memvalid. You can use any signal from the Pico RV32A.V file, input output signal. So then Prabhavati is asking, does the order north, south, east, west matters? Yes, basically I'll show you what north, south, east, west meant with respect to the chip relative. And these are terminologies which are forced by, means the tool only understand these names. Also, to add to Naveen's question, how do you decide pin directions? It's also the external routing ease and also internal to your design routing ease. So if you place, based on how you place different pins, then it depends on the routing may be difficult or easier. No, Zakir is asking if the first north and south. No, that order is not important. I'll give 2-3 more minutes for everyone to catch up, and then we'll do the rest of the changes. Okay, so then the question is, if there is a pad versus pin versus delay, there is a mismatch. Yes, means if you know where the tool is, if you know what is going to ease up routing, right, and ease up delay. So suppose depending on where your block is, inside your block, there might be subcomponents, and those subcomponents might be closer to the left side. If they're closer to the left side, and if they're timing critical and you want to reduce the delay, then you put the pin on that side or pad on that side. So it's all about how you floor plan the internal design, or how the tool will floor plan the internal design. And that's why I said this whole thing is an iterative process. So you might run the design once and then go again and change some of these pin locations, and then rerun the design to actually be able to do this better next time. And then we'll actually show you basically we'll show you towards the end. I'll give you a script. I'll show and run a script where you can do a regression. Okay, if maybe this works, maybe this works, which one of this is more favorable? Zakir, it is deciding on the basis of this north, south, east, west tag, which we have put. These are not comments. These are basically tool is able to recognize these tags. The vectored ports we can do using a star. I'll show you. We'll give different tries. First, let's do one thing, and then obviously you can go back and explore once you know. It's not that hard to just keep changing this file and to test out different configurations. Again, the point of this course is to be able to explain you how things are working. And then exploration is all up to you. That's infinite. Okay, so let's see how we can run just this. I'm hoping everyone has created a pin_order.config inside the Pico RV32A directory. Okay, so now what I'm going to do is I'm going to open the config.tcl of which is for my present in my Pico RV32A directory. So please note which config.tcl that I open. Please do not open. Please do not open any other config.tcl. This is the config.tcl which is present inside my Pico RV32A directory. Okay. And then Vishnuvardhan is asking the only way to set ports is north, south, east, west, south, east, west, or the direction is the direction to set ports like bottom, top, left. Vishnuvardhan also depending on what tool manufacturer defines what terminology. So with respect to OpenLane or OpenRoad, which it uses, they define the terminology north, south, east, west. Usually that is the terminology used is by standard as well. Top, bottom, left, right is usually confusing. It can lead to confusion. That's why top of what, bottom of what. So it is, even it is true in north, south, east, west, but it's just a terminology pick. So that's all the tool understand. So Pradyum is asking, my design is still running. It came to my observation that even without running runs, and this is one of those instructions have been executed. Is it supposed to happen? So if you ran place IO without it, I'm not sure what it did without without an actual thing to run on. I'm not sure what you can just kill it and rerun it. It doesn't take that long. I'm not sure what you're saying, Pradyum. Though I cannot understand, obviously. Okay, so Naveen, yes, I'll take your request and we'll try to have some of this during the routing session. I'll try to include some of these details. What does this mean basically? Okay, so in the config.tcl for your for your design, what we want to do is now basically change it to tell it that you want to source the pinorder.config file. So we need to set this environment variable. I'll let you know this environment variable. I'll type it in the chat box, in the Q&A box. But before I do that, let me explain you how. So fp pinorder config, that's the environmental variable we want to set. What is the path we want to set? I just want to clarify. This is where our pin order.config resides, right? You want to provide this path. So then the design name is Pico RV32A. Or we can do one better. We can actually just do this just to avoid confusion. I'm not passing it by name of the environment variable because it might create confusion and errors at your end. That's why I'm just passing directly the actual name. So you're supposed to set this environment variable at your end. I'm copying and pasting this in the Q&A box, but please, please, please change this initial path to whatever it is at your end. Otherwise, again, you'll get errors, okay? Just don't blindly copy and paste it. So please add this configuration, set this environment variable in your config.tcl, which is present in the Pico RV32A directory. I'll wait for 5 minutes to actually let this happen, and then we'll start working in the tool environment again. So Pradyuman is asking, you ran this command after that means after running this, you have to first run synthesis, then you have to run floor plan, then placement, and clock tree synthesis and routing. That's what we are doing one by one, step by step. So I'm not sure what you are saying. You have to run this in this, you're running it correctly. I'll show you again. I'll go back to that. I'm waiting for people to be able to just make sure they set this environment variable correctly at their end. So Pradyum, you ran all the possible, then you ran detailed routing. So sure, means if you run everything, it will run everything, but then you should, it's not no use running it without knowing what it is running. Again, the point of the course is not to run scripts. It is to be able to understand what is going on in the scripts and then run them as needed for your site. Okay, I understand. It will run optimization, sure. So in open source, with respect to command check, there are hardly any. That's a good question by Suri Krishna. It's command in the Q&A window. I'm not sure. what you're saying. Oh, so if Pradyum, you only, I don't think you must have entered, then something is wrong. Basically, then you did not type interactive correctly or something. If you did not type interactive correctly, then it will run all the stages. Okay, Surya Krishna is asking this command check. Okay, so the environment variable I've set this command. You're supposed to, again, I'm repeating, you're supposed to set it in your config.tk. Please set the initial path for as you're present in your Linux directory. If you do not set it as in your Linux directory, it will not work. This is for my Linux directory where this is file is located. Please set it for your Linux directory correctly. Okay, I am in the meantime, what I'll do is I will run this again just to show you. As I mentioned, I exited from my OpenLane environment. If you the issue with OpenLane usually is it's very hard to rerun. If you change the script and rerun some command, it's most of the time it is not able to identify that what happened. So rerunning something is hard. That's why it's easiest to just rerun the whole thing. So I did the same command, flow pickle design pico rv32a tag test EICT overwrite interactive. Now, as you see here, it is it's saying it is removing the existing OpenLane design pico rv32 test EICT. It removed the old directory and now it is creating it again. Okay, so it will now run different stages of the flow. Now we can run different stages of the flow again. So we'll run the run synthesis again. So please run the synthesis again. Okay. So for my end, it is showing synthesis was successful. I hoping it will be successful for your end as well. I'll wait for a minute for everyone to catch up. So just to repeat what we did, we created a pin order config file. And after creating a pin order config file, what we did was we put an environment variable in our main config file. So the config.tcl inside our pico rv32a directory, we put a environment variable fp pin order config and passed the path to that config directory, pin order config file. Okay. So after that, I went into tool environment, loaded the OpenLane environment fresh. And then I did run synthesis. Now I'm doing init floor plan. So as you remember, synthesis just runs uses synthesis. Init floor plan only creates the boundary. So the area and height and all that got created basically. And it created the temporary def, which is fine. We have already observed it, no point in doing that. Now, instead of place IO, I want to do, earlier I did place IO, I want to do place IO all. So that's the command I want to run. Okay. So I'm sending this command also, do place IO all and see what is the effect. So let's see what my terminal window is saying after I did a place IO all. So my terminal window is giving me a long message. Let's see what it is. Most of the time it is easy to understand what happened when you ran something just by observing the terminal log. So here is where I ran the place IO all. after I ran place IO all, what it said was it merged some lefts, some technology stuff, and then okay, this, it already created this, and then it said some pins weren't matched by the config file. So it is reading our config file, and it is saying that some of the pins were not able to be matched. Now it is telling you the names of the pins which were not matched as well. So this is back to Zakir's question now, that how do we specify the vectored ones? The way you specify vectored ones are like this. And then you specify them one by one as needed, wherever, whichever pin location is. So it is telling you, and it is saying that it assigned random sites to these above pins which were not present. Okay, whatever we specified, it take, if everything went correctly, then it should have just picked the correct direction we specified for those. For the rest of them, it should have picked random values. Okay. Now, how do we observe this? How do we observe what changes we did? So where should it have been saved? It's saying it is saved it in temp floor plan ioplacer.def. Okay, we want to go look at this tag. So it should be in the runs directory. We specify the tag test.eict, so it should be there. Then it should be in the temp, and it should be in floor plan because we are running floor plan stage. Now, what is the file we are looking for? This ioplacer.def. Now here, I'll open it using Klayout. Okay. Let's see what comes up. So what was my config file? In my config file, I said that place clock on the top left, north direction. I gave the direction for the, let me open my config file as well in parallel. Let me put this here. Let's see, where is my config file? Okay, so my config file said that my clock goes on the north direction, so it picked it correctly. That is excellent. Then my config file said that reset n goes in the south direction. It is, let's see, yes, it picked that correctly as well. And then my config file said memvalid goes in the west direction. It has picked that correctly as well. So an interesting question might be, why did it go to the bottom and why did it go to the left? Every tool has a numbering strategy for every direction. So based on that, it picks, it starts the numbering from the bottom or the left side. And then if you see here again on the right side, or east side, it started numbering from the bottom. So the numbers start from the bottom of the left side. So it is picking the names correctly, as we can see. Okay. So I will wait for everyone to catch up and be able to do this. So after run synthesis, you need to do init floor plan. I'll type that. And then after init floor plan, you need to do place IO all. And then this file should exist in your temp directory. I'll wait for everyone to catch up and be able to observe this file. So I'll give you 5-10 minutes to be able to do this. Please take it slow and get this done. Yes, of course, Pradyumn. You need to have created pin order.config and also add the environment variable, set environment variable fp pin order config in your config.tickle. If you've not done that, then place IO all will not work correctly for you. So you can, I mean, pretty much place in, you can specify these pin names. So it in your run script, after you run place I all, it tells you what all pins are not placed. So you can go back and put these in your config play pin order config file in the order you want, one after the other. So for example, you can basically below clock, if I make EOI 0, then it will pick EOI 0 for the after clock at the top here and the north direction. So one after the other, whatever names I put, it will pick those. And rest of them it will place randomly. Please take another 3-4 minutes. Run this nicely, slowly at your end, and then we'll move along to the next topic. Yes, you can do that. That's an excellent question. I am trying to avoid that right now because it creates confusion and people are having issues running the once you get used to it, you can actually just run it from a previous stage. That is perfectly possible. Towards the end of the session, I might just go with some of that technique, but for now, let's try to avoid it because otherwise it creates a lot of confusion. Excellent. So it's working for most of them. I'll wait another 3-4 minutes for everyone to catch up. Excellent. So things are working. Nice. Keep going. Well, I'll still wait for a couple of more minutes because people are like, I would like everyone to be able to follow along. Yeah, I'll repeat after pinorder.config just for everyone's reference. So we created a file called pinorder.config, and after that, in our main config file which is present, we added an environment variable which I pasted in the chat, and this pinorder config, and provided the path to where the pinorder config resides. Please remember to change this path to whatever is in your directory. And after that, I ran everything again from synthesis to init floor plan to place IO all. Okay. Okay. Okay, I'll wait for a few more minutes. It's fine. People are catching up along today, so it's good. Tomorrow we can go a little bit faster. So today we can take it slow. Don't worry about it. It's good. People are catching up. Everyone seems to have spent a lot of trying to. That's basically you should. Yeah, it takes time to get used to this environment, the tool, and everything. I think people are doing an excellent job today. Nice, good job, everyone. I'll wait for 2-3 more minutes and then move forward. Madhav, I think Puneet will address the OpenST issues in the next session. Don't worry about it. These FlexSpice and CMake issues. And then there is a question regarding the float plan. So, okay. Basically, first you type init float plan. And then you type place IO all. And then someone's asking, how do we observe the layout? So the layout is present as a def in the temp directory of our run. So what we provided in the Pico RV32 inside the runs, there is a directory with the tag which we created, test EICT, when we loaded the Floatical. Then we do temp floor plan. Inside temp floor plan, there should be a file, ioplacer.def, which we open using Klayout. Here's what I'm going to do. I'm going to just exit my environment and actually quickly run this again, just for everyone's reference, using a small tweak. And so everyone is able to follow. So basically start my environment, Floatical, design Pico RV32A, tag, test EICT, overwrite, interactive. It removed my old tag library, started it again, run, synthesis. Okay, synthesis was successful. Now what we do is init floor plan. Then we do place IO all, and I'm going to do a small tweak in this command. People can run this at their end, rerun everything just for practice after exiting, or run this later. I'll just still wait for 5 minutes for everyone to catch up on this. You can do a vertical extension and a horizontal extension. Something like this. I'll just copy paste this command. And I'll run this. Now I want to go and observe what is the difference between the old one I did and this new one. Okay. So in my this directory, so I have a temp directory. In my temp directory, I have a floor plan directory. I have ioplacer.def. And let's see what my vertical and horizontal extension commands did. So let's see, K layout ioplacer.def. Does anyone observe a change from the previous layout? Can anyone point out what is the difference between from the last time we did it? Anyone observe the change? I will wait a couple of minutes for people to catch up. Okay, interesting question. Bhargavi. It means the extensions basically. So you have this horizontal IO. Earlier, it was up to your outline of your design. Now this is extending beyond the by 10 micron. It is extending beyond the outline by 10 micron. Similarly, on the vertical direction, this pin is extending beyond the boundary of my outline by 5 micron. So if you suppose create certain sub blocks within a bigger SoC and you want the pins to be extending for better connectivity, then you do a extension on there on those pins. By the time everyone catches up, I want to run one last command on the floor plan side. Okay, I want to run one last command on the floor plan side. Please note that we have not yet covered the sizing and the floor plan ratio, the aspect ratio versus the utilization. I'll want to cover all of that together using the placement density thing. So when we'll talk next about placement density, and we'll start relating this from that perspective. Before we do that, before we go into the placement concepts, I want everyone to run a command called tap decap or. Okay. So I'll let you know the command in the chat box as well. Tap decap or. And after running this command, if you observe that the design is no longer present in the temp directory, it is saying that it is shifted the design to open lane flow design PicoRV32A run floor plan in the floor plan.def. Okay. So we go back. So where does it say? It said in the actual floor plan directory, not in the temp directory. Okay. So it's in the results directory. It's in the floor plan directory. There should be something called PicoRV32A floor plan.def. Okay. So we open this with KLayout. PicoRV32A floor plan.def. And interestingly enough, something has happened in my design. Something has been placed in my design. So basically what these are tap cells and decap cells. So at the boundary, there are decaps, and overall in the whole design, there are tap cells distributed. The reason you need, so these boundaries are decaps, these rest of them are distributed tap cells. How they are actually getting created is dependent on the script. There are few environment variables to change them as well. You can explore them at your own time. But in general, there has to be a minimum density of tap cells to connect through the NVEL and to the substrate in the design. Otherwise, you do not meet the DRC rules. Puneet will discuss some of these rules later on in the DRC LVS sessions. But you need to have inserted tap cells. Otherwise, your design is not DRC compliant and you've not connected your substrate correctly. So in order to do that, what you do is the tap cell insertion. Now, what you observe here is that your design is now completed floor plan stage and can go into the, because it has been shifted to the floor plan directory. Now, can someone point out what did we miss? If we have done the floor plan, we discussed something yesterday. which we have missed doing the floor plan stage. One of the commands has been missed. What's that command? Can someone tell me that? In the meantime, I'll answer Rajesh question in terms of what are the tap cells. So what we mean by tap cells is basically you need to connect your substrate to ground and your NVEL to VDD in regular intervals in the chip. Otherwise, you do not get a correct, you have DRC violations. Your substrate becomes floating or your NVEL is floating. So that's why you need tap cells in your design. And Ruel is pointing out correctly that we missed the PDN command. Excellent. So what I'll do now is I will rerun the whole script using the PDN command as well before we go into the placement stage. And in the meantime, I want everyone to take the next 5-10 minutes and catch up and also run the whole thing nicely and cleanly at their end. So what we'll do is we will do exit here. We will do // we'll rerun this. I should exit this. We'll rerun this. We'll rerun synthesis. We'll do init floor plan. Then we do the place IO all. Then we do PDN gen PDN. Then we do tap decap or okay. And then I go back and look in the floor plan directory. Okay. In the results floor plan directory. So floor plan. We have a PQRV32A floor plan.def. Let's try to open it. Now, as you can see, where did this go? Okay, my bad. It's going up, but we can zoom in and zoom out. Okay, nice. Now, as you can see, I have my power grid. I have my tap and decap cells also placed in the power grid. I can get rid of metal 5, metal 4. So you can see nicely. I have my M1 power grid. I have my tab decap cells all placed nicely in my power grid. And I have my VRs dropping from M5, M4 to my lower level M1 power grid as well. So I have done basically at this point, my floor planning is complete. Okay. At this point of time, my floor planning is complete. I'll wait next 10 minutes for everyone to catch up to this point. Okay. Then I will explain some other commands with respect to the aspect ratios, the density utilization, and all those things. But please, everyone should catch up first to this stage. I'll wait next 10 minutes for everyone to reach this stage, having completed the floor plan correctly. Yes, Ruel, you are absolutely correct. Okay, Venkat is getting an error that there is no variable called fp pin order config. That's what basically means that you have actually not put the pin order config. So I will, since people are getting this error, I will repeat the steps which you might have missed. So earlier, we did two things. We did so in my Pico RV32A directory, I created a file called pin order config, and then I did another thing which people have missed evidently. They created you have to create a variable, you have to specify a variable in your config.tcl. So you have a config.tcl here. In that, you have to specify this variable over here. So in this, you have to make sure that the initial path over here points to your directory correctly. This is my directory. Make sure you change it to your directory address. And Naveen, yes, you have an excellent question. That is basically the today's target, next half an hour or so. We want to discuss basically what does aspect ratio, size, die area, utilization, placement density, how are they all related to each other? We want to have some time to discuss that basically. So don't worry about it, we will address your question. George, OpenLane also runs synthesis. The issue with the reason we did not run synthesis using directly OpenLane initially is because it limits the freedom to exploring the design. Because of the way that it is structured in a tool environment. With directly running uses, you had a lot of freedom and you could understand different stages of uses. Sorry, synthesis in general, and it lets you better appreciate what happens during synthesis and how do you use it. So again, that's like a usual error. The only reason you get an error is you do not specify the path correctly. Make sure you do like what you select. The easiest is select this whole thing, do more and more on that path. And if you do not see a directory over there, then basically, sorry, my bad. So do a more on that path. And if you are not able to see a config file, means you did not specify the path correctly. So if it doesn't read the path correctly, means you did not specify the path correctly. Yeah, so with respect to this IO pin placements and routing and a little bit insights on low power, we will discuss some of this on the routing session. I mean, for sure, in the next couple of days. Then there we are planning to discuss a little bit again from the low power perspective towards the end of this program again. Okay, I'll wait another 5 minutes to catch up, and then we have some other insights with respect to what Naveen was earlier asking regarding the placement density, floor planning density, and all those things. We'll discuss those topics next. I'll wait another 5 minutes for people to catch up. Okay, Gauri is asking pins are not in the specified direction. Then Gauri, something might not have read, your file might not have read correctly. It means after it, you do a basically place IO all, it actually tells you which pins it is randomly placing, which pins it placed in the correct direction. Go look at that log, it will let you know what happened. I'll wait another 5 minutes just for people to catch up. Sure, George, I can do that. It's a matter of habit. It's over time. Let's wait another 5 minutes. Okay, how do we know the exact pin numbers to define for industry design? So pins are actually decided when by the RTL designer, right? You do not design from the implementation flow perspective. You do not design the pins. Pins are whatever the IOs for your whichever design hierarchy you are working on. If you're working at the top level, then they connect directly to pads. And if you're working in a sub block, then whatever RTL designer gave you, those are your pins. So what I'm going to do is I'm going to exit this environment over here. I am going to take this terminal, put it over here, let's go back. Okay, I want to go in the configuration directory, okay? I want to go in the configuration directory. So next 15-20 minutes, we would like to understand first what different density options, size options mean, and then how you can change them based on your design. Okay, so I want to explore that from the configuration files. Then I would request you guys to run the flow again from scratch and try to see did it make a difference. Okay, so that's how we'll target this. So let's start with floor plan.tcl. Okay, in the floor plan.tcl, this let's leave this. Okay, let's start with this IO metal. So what does this IO metal mean? You right now in the place IO, you placed some metal pins on the horizontal and vertical directions. What are the horizontal and vertical direction pin layers? So if they're picked layer 3 and 4, you can change them and rerun the flow at your end. And that lets you change the IO pin layers, basically. Okay, I'll go along and explain all of this, and then I'll wait and for any questions you guys might have. Okay. Then the next one, which is important over here, is this sizing, which was a question from one of you guys as well. Okay, so how do we decide sizing? So let's try to understand it from the design perspective. After synthesis, you have a gate level netlist. Now, if you do a straight up gate count, and you will be able to approximate the rough area those gates will take. That is exactly what the tool does. So the tool is able to estimate, okay, this is the rough area my gates are going to take. Okay. Now, if I tell the tool that that gate area is how much percentage of my design. So here I specify that 20% of my area is what actual my gate count is, and 80% should be empty. That's how I specify the utilization. So utilization tells how much area would be used by my gates. So if I tell the FP core utilization. Now with this, I have specified the FP sizing relative to be value 4. Sorry, FP sizing to be relative. This means that it will take that gate count, assume it to be 20%, and then blow up the entire area to be whatever needs to be. So it will create a relative area based on my gate count area and my utilization, which I have specified. It will create 80% more area, and that will be my total area. Now, with respect to the X and Y dimensions, that are decided by this aspect ratio. I can set it to be 0.5. So aspect ratio is X by Y, X direction by Y direction, and I can set it to any values, and that relative area would then be changed accordingly. So any questions on this? Because next what I'm going to do is I'll ask you to change this and run the Pico RV32 design again and observe the layout. For example, in my end, I will only change the aspect ratio and run it, but you'll change the other values as well and rerun this design. So let's do vim floor plan.pickle. Insert, let's make this 0.5 and see what happens. Escape WQ. And let's run this again. So I'm going to, okay, so there's some issue executing this. I need to check. Okay, I forgot a space here. I do WQ. Okay, then I rerun the script and then it ran again. So I'll do a shortcut right now. What I'll do is I'll do first run synthesis. And let synthesis complete. And then after that, I'll do run, basically floor plan. So run floor plan is a superset of all the commands that init floor plan, place IO, and to tab decap, or everything is done using run floor plan. So it's a superset of commands. So I just ran the run floor plan directly just to observe my final output. So right now it's saying that it is present in this directory. So yes, you can obviously change the horizontal and vertical IO CS, and what is going to happen is it will actually change. Again, it is based on your system level. Which layers do you decide to route those signals based on which layers are available for your block? And these are all decisions which you have to make at system level planning. So we'll go in the runs directory to test, and right now it's saying that it is still in the temp directory because I think it did not run the tab decap or. So let's go in floor plan, and then it's saying it's in the pdn.def. Okay, let's observe this pdn.def. K layout pdn.def and see what comes up. So does anyone see a change here? Basically, my aspect ratio has changed. So X is now bigger and Y is smaller. So evidently it's y by x. Similar lines, you can go ahead and change. I'll exit this now. I'll exit this now. I'll let everyone catch up and do this. But on similar lines, everyone can actually go and change, say, the IO metals, they can change the utilization, they can change the margin, and see that your design size will actually change. Okay. Now, I'll let you guys do it in like 2-3 minutes. I want to explain a few more things before we do that. So suppose you did not want it to be relative and you had a fixed core area or a die area or a block area, then what you can do is you can also specify an absolute size. At that point, you do not have any control on the utilization. So you can, what the commands I've commented out, you can say sizing to be absolute and then just specify the die area. In that case, the way the coordinates are specified are like this. We'll come back to this nomenclature when we are doing some routing blockages as well. But in general, this is the XY for the left bottom of the rectangle. And this is the XY coordinate for the right top. And that's how you specify the die area. So you can go with the absolute die area as well if you know what size you have to fit it to. So at this point, I would let everyone actually spend next 5-10 minutes and change some utilization, change the aspect ratios, and be able to rerun this design. Okay. Okay, I'll let everyone run this. So, interesting question by Surya Krishan. Surya is how do you measure the impact of system? So you have to define a spec for system, right? If you reduce the area, if you have a higher utilization, you'll be able to reduce the area, and then basically if you can reduce the area, your system is better, but you may not be able to do routing in there. Why? Because even if you take 50% utilization, your clock tree might be really complex, and your utilization because of all the clock tree elements might go up further. We'll come to all those concepts later. So, and if you pick a really big area, then your clock distribution network might consume crazy amount of power. So yeah, it depends on what is needed at that point of time. You have to define a spec to measure the performance, basically. So cell area will be known to us by synthesis, and then we need to perform floor plan routing. Yes, that is correct. This open source tools do not report the power, Zakir. Narsimha is saying, yes, because there were some synthesis issues, we changed the design. If you join late, I would advise you to go and listen to this lecture in YouTube again. Naveen, basically, if you know the cell area, usually a good estimate is you assume it to be around 40-50% of your total die area, because another 10% odd would increase in the CTS. And then in order to have decent routing and flexibility later on, you should not exceed your utilization at the end by more than 50-60%. That is for conventional tools. But for your open source tools, they do not have fancy routers. So it is very hard to hit higher utilization than 20-30% in complex designs at all. So CellPad 4 is not metal layer. We'll come to the CellPad in a bit. Don't worry about it. Okay, I'll let you guys run this. Run floor plan, yes, it runs PDN, Gen PDN, but it doesn't run evidently tab decap, or you need to still run tab decap or. or it might just be not running it on my end. You can check. It tells you where the design is saved, what all did it run. It all gives it all in the log file. So please run this at your end. I'll give you 5 more minutes, and then there are some closing thoughts I want to leave with. We'll discuss some other concepts, and then we'll call it a session today. So relative and absolute means, Naveen, that if you have it at relative and you specify the utilization, then it will assume the cell count area to be the 20%, and then it will create 80% more area, and then it will create the total area relative to your utilization. With absolute, you tell the tool what is the area. Then you do not have any control on the utilization. It is, the area is what it is, right? Because your cell count is what it is, your area is what it is. You do not at that point have any control on the utilization. Commercial tools, yes, Naveen, that is fine with respect to the assumption, but in open source tools, it is hard to achieve 50% utilization, as I pointed out already. Yes, George, you can comment out that line. The other 80% is not for macros, because macros should be accounted for your die area already. Some of it is for the clock tree cells, which are not in your design yet. Some of it is because the routers in open source are not very fancy, so they're not able to achieve good routing and placement also if you do not specify, if your utilization is not low. Zakir, people are working on some open source power analysis tools, but there I am not aware of any good ones yet, which give you reliable numbers. I think someone from IIT Bombay was working on it. I'll need to double check. For particular technology, we have to use different metals, PDK metal. Because different technologies have different number of metal layers, Naveen. That depends on the technology cost, technology provider, what requirements of customers and stuff like that. So okay, so I hope everyone is able to run this design again in the background. I'll give another minute to everyone to catch up. Vishnuvardhan, as I pointed out, utilization is specified as to how much area does your cells contain, and the rest of it is empty. And you have to keep low utilization in the two open source tools to be able to achieve placement and routing. Typically, you keep a margin for in commercial tools, you keep a margin for, say, the clock tree which gets created, the routing channels which may need to be created, the echo which might need to be done later on. You have to keep a margin for everything. Okay, so now that we are done with this, I want to give a brief about what is the target in the next upcoming lectures, just so everyone is able to understand where we are, what we are targeting. So currently, okay, let's do a few. So yes, Sakir, I'm not sure exactly the question you're asking. If you could explain a little more. So basically, right now we targeted the floor plan.tickle. So tomorrow we'll target the placement.tickle, and then we will also try to do some manual macro placement and try to see how that happens. And then I'll give you a to do yourself to do manual macro placements for your risk course. Then basically, as we go along, then we do take quick sessions on CTS and routing, and then we'll do some regression testing scripts, and that is going to be it. Now that you guys are fluent with the tool, it will move a little bit faster in the next couple of sessions, and we'll cover up the little leftover portion. Zakir, yes, synthesis, floor planning, placement. In floor planning, IO placement actually happens, and after placement, there is clock tree synthesis, then there is routing, and then there is the RC LVS and all that. So, okay, so any other questions, or we can call it a first session? I think it was an excellent session today. Okay, Zakir, good question. You do the placement after your power rails. I think today's session was nice. Everyone did work hard in yesterday and was good. Everyone was did followed along nicely. So excellent work. I'll upload today's session. And then we'll follow along with the next sessions on similar lines. So yes, please try to explore the tool environment more. That way we can do the next steps faster. You can ask more informative questions. Don't just run scripts. Running scripts is not useful. Explore the tool environment, tool directories that lets you understand tool mode. Running scripts just to run a design is useless. Okay, so I will stop sharing at this point, and I can give control to Firoza ma'am. And ma'am, yes, now Puneet can follow up with the next session in like 5 minutes.
Thank you, Aditya sir. Thank you for your excellent presentation for the day 7 of the program. So we request all the participants to please have a break of 5 minutes. So after the break, we will start the next session by 11:31. It's 11:26 right now. So we will start the next session at 11:31. The next session will be taken by Mr. Puneet Mittal, sir.
Hi, Firoza ma'am. Am I audible?
Yes, sir. You're absolutely audible, sir. We are giving you this sharing rights. Please hold on for a second.
Okay. And can you just let me know if there is any background noise from my side? Or is it okay?
Yeah, your voice is absolutely clear. No background noises there.
Okay, great.
Thank you. Hello.
Yes, ma'am.
So we have made you the presenter.
No, I don't think
So
so.
you can, yeah, it's done
Okay.
now.
Okay, now. Okay, let me just try.
Okay.
I think now it's visible.
Yes, sir, your screen is absolutely visible.
Okay,
So
great.
we will start the next session by 11:31, sir. Thank
Okay.
you. Thank you, sir.
Okay, everyone. So now I think we should start. It's 11:32. Okay, great. So yesterday we were discussing a couple of things. So what I'm going to do, I'm going to discuss those things once again because few people just requested yesterday, like, okay, they need to understand the whole check again. So these slides, already you have these slides. So I'm just going to discuss that particular part once again. So setup and hold, we will discuss. Now, when it comes to, okay, tool. So people are saying not able to install OpenSTA. So I'm a little bit surprised, frankly speaking. So I saw a couple of you guys, you guys have posted the error, and it looks to me like uh, uh, you haven't tried it on a Google. So like yesterday, I have mentioned every people have their own environment related challenge, like the Ubuntu or maybe some setup related thing. So you guys just try that particular part in a Google. Just type uh, that particular message as it is, and I have seen like the snapshot which I have seen yesterday. Apart from the Naveen, I think Naveen was facing some problem, and I didn't have any clue. Like, okay, why he's facing that particular problem. So I asked him if he can just give me the snapshot of the error. But looks like just right now he mentioned like, okay, he was able to uh, install after upgrading the Ubuntu. So Surya, I'm not sure like, okay, why you're not able to install OpenSTA. Maybe you haven't tried it, just checking the error. What is the error code? And if you will just try it on a Google, then you will find the solution very easily. So most of the error usually happen because of missing some package. So the best thing is you have to just install that particular package. That's all. So that's my learning. Uh, so I think Surya, like you are saying, you tried but not succeed. Okay, so why can't you just do a fresh installation again? So uh, I'm not supposed to say in this particular forum, but I think most of us are engineers and most of us know how to use Google, and most of us know very well like the solution of each and every problem. So the problem is, so all these problems are not something which is you are facing first time. I'm sure like, okay, someone else already faced that particular problem, and if you will find properly, you will find the solution of that problem on the Google very well. That's my learning, and that's the reason I'm just requesting all of you just try it uh, on your side once. So because installation should not be a problem if you just follow certain steps. Yes, these are open source tools, so sometimes they have a dependency on the couple of packages, so you have to just install those packages. Okay, so apart from Surya, anyone else face a similar kind of problem? Let's do one thing. Is if you can use this Q&A window and just let me know, like how many of you are able to download OpenST properly, install OpenST properly. Can you guys just say yes or no? So yes means you're able to do it, and then you tried the commands which I have shared with you yesterday, day before yesterday. And if it is no, then just let me know no also. So I need to understand, like out of 300, 400 people, how many of you are able to do this particular part? Okay, so people are saying they are able to do it, but in some other platform, I think that's okay. Okay, so Surya, yes. So if you're going to write same thing 4 or 5 times, you're not going to increase the votes. So your vote is going to be considered the one. Mm-hmm. Okay, what about other people? Only 4, 5 answers. What happened to other people? Yeah, so most of the time you're going to face a problem in the last command only, because if something is not installed properly, that means it's going to give an error. And it will give an error like, okay, why, what is the error? And then you have to just install respective package. Okay, so it looks to me more, because you guys are not replying here, so that means all of you are able to install it except 1 or 2 people, and all of you are guys are ready to do certain I would say the hands-on today, because today is going to be mostly on a tool side. It's going to be the maximum the report, and I'm going to just explain you the report side, what is inside the report, how to analyze that particular report, basically how to read and how to understand that particular report, and what are the different things you're going to change, and that's going to change the report also. Okay, no answer, no one. Okay, let me ask then the another question. Setup, how many of you are okay with the setup time? Any confusion here? If no confusion, then I will just move forward. Okay, no confusion. Okay, great. Okay, great. Yes, I'm going to explain the whole time. I will just check it. Yes, will do definitely. Hmm. Okay, so looks like only few people, 4, 5, or maximum 10 people, they are active right now. Apart from that, everyone just join for sake of maybe the certificate or for the sake of attendance. Looks to me. Okay. So Surya is saying my video is very low. Is it for everyone? Surya, maybe you can just increase the volume in your laptop or maybe the phone. Okay, voice is low. You want me to? Okay, great. So it's a mixture of low and loud and good and clear. Okay, let's see. So now let's talk about the setup. Setup is done. I think yesterday we have discussed very clearly what is the setup time. Now this is the thing. One portion which I want to highlight here today is there are two type of Slack. One is setup Slack, another is a hold Slack. So what is a setup Slack and a hold Slack? And if you will see the definition of setup Slack and a hold Slack, like the way from the equation point of view, or if you are thinking from the how you're going to calculate the setup and hold Slack. So basically, these are the two terms. One is a data required time, and another is a data arrival time. Now for the setup Slack, if you will go in this particular figure, now in this particular figure you know very well. So what is happening? Like we are talking about this thing. This is our arrival time. So this arrival time and this is our required time. So in a setup time, what we need arrival time should be less than the required time. Remember yesterday we have discussed like, okay, the data should reach certain time before the clock edge. So that's basically arrival time should be less than the required time. So if we are going to calculate the setup slack, then it is going to be the required minus arrival. So remember this particular part, that means required is going to be greater than the arrival, and that's the reason we are talking about the setup slack. Now, if the same thing we are going to discuss, and if we will talk about from old point of view. So now let's try to understand once again what is the hold check. So the hold check is basically you want to hold the data. So there was a data A. Now this data A is traveling here, or let me just draw maybe that in this particular way. Yesterday, because a lot of people were facing some confusion here. Now let's try to understand once again. So this is the data which you are going to launch from this particular edge, that is a data A. The data which you are going to launch from this particular edge, that is the data B. So this is a launch clock and this is a capture clock. Okay. Now, obviously, so if you're going to launch a data at this particular edge, let me just mark it as a 0 nanosecond. Let me mark it as a 10 nanosecond. Here it is again 0 nanosecond. This is a 10 nanosecond. Now try to understand, just pay attention here. So if you're going to launch a data at 0 nanosecond, then you cannot capture this data at 0 nanosecond. You're launching here, you cannot capture here. That means it's the same thing. You cannot present the two location at the same time. So that means if you're launching the data at 0 nanosecond, you can capture that particular data at 10 nanosecond only. And as per the flip-flop constraint, as per the flip-flop condition, they said like, okay, you should reach certain time before the clock edge because this is your clock edge. So data travel, and if the data will come somewhere here, there is no problem. So this is basically the setup. Now why there is a setup check? Because flip-flop, the capture flip-flop is saying when I'm going to capture the data at 10 nanosecond, I'm giving you the guarantee, assurance. Like, okay, I'm going to transfer your data from D2 pin to Q2 pin. That means from input to output. But now the second thing come into the picture. So the second thing is you're launching another data from B. And let us suppose this B reaches very fast and it reaches somewhere here. So this is the analogy which I gave you that particular day, yesterday basically. I gave you the analogy like, okay, at this point, you're boarding a plane. And after boarding a plane, it is going to take maybe some time to fly. It will take some time, and that is that. Let us suppose the time is this. So within this window, if something will happen, if something will happen, so if in the sense, if some other passenger will come and that particular passenger have more strength or the power, then what is going to be happen in that particular plane? There are chances. You can say there is a possibility of 1%, but yes, there is a possibility. There is a possibility of 1%, like the other passenger can replace you because of any reason. That passenger has more power, more money, or more influence or anything. But that can replace you, even if it is a 0.1%. So when the flip-flop is saying, I'm giving a guarantee, but that's not a guarantee, because now even if it is a 0.1%, some other data will come and replace you. Some other data will come and replace the previous data. That means flip-flop is not giving you the guarantee. So the what flip-flop is saying, or you can say what the airlines people are saying, they are saying, we will make sure this data B will not reach, or it will reach. It will reach after this time. After this time. It will reach only after this particular time. And if it will reach after this particular time, then there is no problem. So as a check, the check is there are what the airport authority, what the check they have to do, what they have to make sure. Like if the data B is coming and it is coming very early, then they will stop. They will say like, okay, no, you cannot go here. In case of a circuit, we cannot stop it. But we can say if the data B is coming somewhere here, that means there is a problem. And then they will, the analysis tool will tell the designer, like, you have to fix this particular part. Okay, so Venkat was asking the data coming during the hold stable state, the output will be in a meta stable state. Yes. So meta stable state is like basically you don't know what is going to be your state. So forget about what is a meta stable state right now. That's I think you can go back and you can just check the digital electronics and figure out. But the point is you're not going to get the data 100% correct. That's a very important point. And now you can ask me two questions. Question number one, how come this data will reach within this window? Because between the flip-flop 1 and flip-flop 2, there is a, so if you will say like, okay, this is my flip-flop 1, this is my flip-flop 2, there is a combinational logic here. And if I'm saying that data A will take certain time, then data B should also take certain time, same time. You can say like, okay, data A, if it is taking 5 seconds, then data B should also take the 5 seconds. How come data A will take more time and data will take less time? So answer of this particular question is, when we were talking about the delay, so if it is your cell, if it is your some combinational logic or maybe it's a cell, at that particular time, we have to calculate the delay of this particular cell. In STA, when we are talking about the STA, so if you remember, we have discussed the delay of this particular cell. We will talk about for the rising edge or for the falling edge. And we know very well for the rising and the falling, there are chances like it is going to be two different delay. For example, for rising, it is giving you 5.1 nanosecond, and for falling, it is giving you 5.5 nanosecond. That means now we are talking about the two delays. One is 5.1 nanosecond, another is 5.5 nanosecond. So we usually talk about like, okay, there is a one minimum delay and one maximum delay. That means every cell has a minimum and maximum delay. Every cell has a minimum and maximum delay. So now let's try to understand again. Let me just erase all this. Let me give an example like, okay, you have a cell, combinational cell like this. So there are two flip-flops. It has a minimum maximum. Let's take for your understanding 5, 6. Everything is a 5, 6, 5 nanosecond, 6 nanosecond. So if I will ask you FF1 to FF2, what is the overall minimum delay? Then you will say it's a 4. The minimum is 4 first 20. It's a 20 nanosecond. Maximum is 24 nanosecond. Now, if this point is clear, now let's try to understand from the data point of view. So you are saying like, okay, data A at a clock this, you're launching it. Now you want to understand at what time it is going to reach at a FF2. So launching a data A and you want to understand at what time it is going to reach at a FF2. So if I will ask you like, okay, you should reach airport before 9:30 from your home. And if I will tell you like, okay, it is going to take half an hour to 45 minutes and you have to reach by 9, let us suppose by 9. You have to reach by 9 and from your home till your airport, it is going to take 30 minutes to 45 minutes. And now you have to do the analysis. You have to do your planning. Like, okay, whether you will you want to reach airport by 9 at any cost, because if you will not reach, then you will miss the plane. So can any one of you just type on a Q&A and just tell me which time you are going to consider for your analysis, for your purpose. So 9 you have to reach, minimum time it will take 30 minutes, maximum time it will take 45 minutes. By when you will start from your home? By when you are going to start from your home? Can you just type and just let me know? Pawan, it's not 8:45. By 9 you have to reach, minimum travel time is 45 and minimum travel time is 30 minutes and maximum is 45 minutes. Yes, it's a 8:15. So that means you're going to consider the maximum time because you need a 100% surety like, okay, I should reach before 9 because if I will not reach before 9, it is going to create a problem. So basically, let us suppose if this is your capture clock, and if I'm saying like, okay, you should reach before this, then as per you, you are going to make sure like, okay, if I will reach from here to here in a 24 nanosecond, whether I'm reaching before this green light or not. At the moment you come to know like, okay, even if it is a 24 nanosecond, I'm able to reach before this green line, then you are happy. You are saying like, okay, now there is a no setup violation. Everything is good. Am I right? Is it clear? Is it clear? Yes or no? Yes. Now let's try to understand another thing. If I will tell you like, okay, you cannot reach before 8:30. So the point is someone just mentioned 8:15. So 8:15 anyways you have to start from your home, but you can also start at 7. So if you will start at 7, it will take 45 minutes. By 7:45 you will be at airport and no problem. If you will reach at 7:45, there is no problem, because what is the condition? Condition is you should reach before 9. Before 9 you can reach any point of a time. So if you will start at 7, you will reach by 7:45 maximum. That is okay. Am I right? Yes or no? Yes. Now, if I will give you another constraint. Now, if I will tell you, you cannot reach before 8. You cannot reach before 8. So that's that's this line. Now I'm saying you cannot reach before this. No, because if you will reach before this, then you're going to create a problem with some other data. The data which I'm trying to capture at this particular edge. So you cannot reach before 7. Let us suppose if I'm going to tell you this thing. Sorry, before 8. Then you cannot start at this. So then what you're going to do, then you will do the analysis in such a way, like, okay, at what time I should start, even in the worst case, even in the best case, I should not reach there at 8. So that means now if I will ask you like, okay, at what time you're going to start, then you will say, okay, minimum time is 30 minutes. I should not reach at 8. Even in the best case, let us suppose if I will consider the best case, if I will start at 7:30, if I will start at 7:30, in the best case, I can reach at 8. But everyone said there is a rule, there is a constraint that I should reach after 8. So that means now you have a window. You cannot start before 7:30. You're going to start after 7:30 and you're going to start before 8:15. So now you have that particular window that, okay, you have to start after 7:30, but you have to uh, start before 8:15. Then only you can reach at airport meeting all those two constraints. The first constraint is you should reach before 9, and the second constraint is you should reach after 8. Is this clear to everyone? Any confusion? Because if this is clear, you can easily understand setup and hold both. Is this clear? Yes or no? Great. So now people are clear this particular part. Now let's see how I'm going to. Okay. Now this portion is clear. Now let's see. It is basically this way. So now in my example, what is happening? I'm telling you like, okay, you have a variable start point, but in our circuit, the start point is fixed. That is at this edge. So you can start at this particular time. That is fixed. That means someone was telling you like, okay, you have to start. That is suppose 7:45. At any cost, you have to start at 7:45. That is fixed. So in our example, 7:45 is fixed because the clock is going to trigger at 7:45. So you have to come out from your home. Now you have to analyze like, okay, the first condition is you should not reach before 8. So how you're going to do the analysis? You will say like, okay, what is the minimum time to reach at airport? So minimum time is 30 minutes. So if I will start at 7:45, I will reach after 8:15. So that means I'm satisfying first condition, no problem. Now, even in the worst case, so worst case is a 45-minute. That means if I will start at 7:45, I will reach even in the worst case, I will reach at 8:30. If I will reach at 8:30, is it before 9? Yes, it is before 9. So that means this condition is also met. So these are the two conditions. In this particular way we are going to do the analysis. Now let's try to understand the same thing with the help of this particular circuit. So if this is your circuit, now in the circuit how we are going to do the analysis, let's try to understand that particular part. So I'm saying there are two flip-flops, there is a combinational logic, there is a clock. This is going to trigger at 0 nanosecond, then the 10 nanosecond. This is also going to trigger at 0 nanosecond and the 10 nanosecond. Now, if I will tell you like, okay, there is a minimum delay of 5 nanosecond and there is a maximum delay of 8 nanosecond. Now the setup time for this is a 2 nanosecond. This is a setup time, and the hold time is 3 nanosecond. Now let's try to understand this thing using a waveform. So basically, I'm going to capture the data at this particular edge, which is a 10 nanosecond. Or maybe I can draw this waveform the other place. So let me just draw it here. So I want to capture it here. So as per the setup, data should reach before this, which is a 2 nanosecond. That means this is a 2 nanosecond. Data should reach after this, which is a 3 nanosecond. Let me use some other this. This is a 3 nanosecond. Same thing is going to be happen for the next clock also, because every clock is going to capture some data, and at each and every clock we are going to do the same analysis basically. So same thing is going to be happen here. 1 second. So this is a white and this one is red. Now let's try to see if you have a data B, maybe some other color, green color. Yes. Now for the B, what is the condition? B should reach, because this B data, we are going to launch it here and we are going to capture it here. So as per the setup, this B data should reach somewhere here before this. If it is reaching before this, then this particular edge is going to capture the B very well. And as per the hold, so that the B should not create any problem to this particular edge, because the constraint for this flip-flop is you should reach after this white line and you should reach before this red line. So before this red line, so for B, it will travel here and we have to see like, okay, what is the delay? And then we will discuss, okay, what is that number? And another condition is it should reach after this, after the white line. And if both the things are meeting, then there is no problem. That's the same thing we have discussed. You should reach after 8 and you should reach before 9. Same thing is here. You should reach after white line. You should reach before red line. Now let's see as per the circuit whether it is happening or not. So this point is 10 nanosecond. Okay. Then 10 plus 3 is a 13 nanosecond. So we have a window like, okay, you should reach after 13 nanosecond. And then this point is basically 10 nanosecond. This point is basically 20 nanosecond. And we are saying setup time is 2 nanosecond. That means we have a window of 20 minus 2, that is a 18 nanosecond. That is a 18 nanosecond. So the data B should reach within this particular window, after 13 and before 18. And data B we are launching at 10 nanosecond. Now you have all the data. We are launching at 10. It should reach after 13 nanosecond. Now what is the minimum delay here? Minimum delay is 5 nanosecond. That means it will reach, even in the best case, it will reach at a 15 nanosecond. What is the maximum delay? Maximum delay is in a 88 nanosecond. That means 10 plus 8 is 18. That means in the worst case, it will reach here, just here, which is a 18 nanosecond. So that means as per this circuit, data will reach best case 15 nanosecond, after 15 nanosecond, or that is the best case. In the worst case, it will reach before 18 nanosecond. So that means in our example, it is meeting both the condition, setup also and the hold also. Is it clear till this point? Any confusion? So Shreyas, I will answer your question. First, let me just check with everyone whether they understood this particular part or not. Please guys, at least you should say now, clear or unclear. Great. Just few more people, if they will say clear, then it is good. And hold on your questions. I will answer all of your questions. Okay, great. So now all of you are clear whatever I have explained you till now. Now let me once again clear this particular screen, and let me now, not the complete screen, maybe the little bit. Let me just clear this portion. Okay. Great. Now, so now let's try to understand from the equation point of view or from the analysis point of view how you're going to do the analysis. So what is basically the analysis? I think I should clear this whole diagram because I just want to make another one. So now let's try to understand with this waveform. Now what I'm doing, I'm just shifting your capture clock little bit because now you will get a clarity what I'm just talking about. So there is a data A, there is a data B, there is a data C. And if you are going to capture the data A, so data A, you're going to, so when we are doing the analysis, we have to find out the edges, like if we are launching the data A from here, at which particular edge we want to capture. So that's, we are usually talk about the real edge. So what is a setup edge? What is a hold edge? So now we are trying, I'm just trying to explain you from the edge point of view. So for the data A, the edge is this. That means you're going to launch it from here, you're going to capture it here. You're going to launch it here, you're going to capture it here. And similarly the C, you will launch it and maybe some other edge. So when we are talking about this particular edge, then the setup we are going to discuss, we are going to talk about the setup now. So setup is this is a setup. That means the A should reach before this. B should reach before this. Now at this particular edge, we want A should be stable. A should be stable certain time after the clock edge. A should be stable certain time after the clock edge. That is the one thing. A should be stable before the clock edge. A should be stable after the clock edge. And that's certain time we are talking about. Now, before the clock edge, if we are talking about, then A can be stable if the A will reach early. So if A will reach somewhere here, then that means it is going to be stable. And that's the reason we are talking about the setup. We are talking about that A should reach before this particular time. Now, the second thing is, once the A will reach here, and then we are saying A should be stable certain time after the clock edge. And what is that time? Let us suppose we are talking about this particular time. After the clock edge, it should be stable for certain time. It should be stable for certain time. So in our case, A should be stable certain time after the clock edge. Now the question comes, when A already reached here, A is somewhere here, who can unstable that particular data? So in a flip-flop, this is my D pin. Now A already reached here. A in the sense the data. Now what is that data? Data is a 1010, whatever the one. That is not in terms of a voltage. So let us suppose one, or you're saying, okay, 1 volt that is already reached here. Now once the data is already reached here, who can change the stability of that A? Only in one condition, the stability of A is going to be, yes, you're right, is going to be changed. That is because of the data B. Now, if the data B will reach somewhere here, then there is a problem. That's the reason we have this concept like, okay, data B should reach after this line. So that means when we are going to do the setup analysis, then we are doing the setup analysis this and this edge. So this particular edge and this particular edge, we are doing the setup analysis. When we're going to do the hold analysis, then we are talking about from the analysis point of view, we have to make sure data B should not reach before this white line. So how you're going to do that particular analysis? For that particular analysis, you will say like, okay, now I have to make sure the data B should not reach before this line. And for that, what you're going to do, if I will talk about the edges, then you will say like, okay, this is my edge. This is my edge. So this edge is going to be the hold edge. and this is my setup edge. That means when we are going to talk about, when we are going to do the analysis, then we are going to talk about this and this edge. This and this edge. When we are going to talk about the setup, then we are talking about this and this edge. So if you will see the setup edge, there is a time. There is a time t. In a hold edge, this is a time period basically. In a hold edge, there is no time t. It's basically this clock is basically shifted in the right hand direction. If it is not shifted, if it is 100% overlapping, it is the same edge. But in this particular case, it is shifted. But edge is edge. So you can say like, okay, there is some certain delay is there. We will discuss that thing in the report, what delay we are talking about right now. Or maybe I will just show you in the circuit also. But right now, it is, you can say it's the same edge. Here you can say it's a different edge, or you can say it's an edge after one cycle. And that's the reason if you will see in a hold, most of the people, they are saying it is on the same edge setup. They are talking about different edges, or you can say after one clock cycle. Is it clear till this point? Any doubt in hold now? Okay, so the one, let me answer in the meantime. Two questions. One is without taking launch flip-flop, the capture flip-flop is not possible understanding the timing. So Zakir Hussain is the timing. So right now we are trying to understand the timing between the two flip-flops. That means register to register. But timing you can understand between input to register also, and between register to output also. But that is going to be the similar type of concept. It's very easy to understand between flip-flop to flip-flop. So that's the reason I took that particular example. Now there is one more question. Okay, so I think Venkat was trying to ask a written thing. Let me. So Venkat, somehow I missed your question. Can you just okay, you are talking about if the data come during the whole stable state, the output will be in the metastable state. Yes. If you're talking about that, yes. Now let's see Bhargavi. One question like, okay, sir, anyways, data launched by FF1, okay, at a second pulse, yes, is going to override the data present at FF2, 100% right. So data launched by FF1 at a second edge, it is going to override the data present at FF2, yes. Why we show maintain hold time then? Does we parallelly take the data out during the hold time? Good question. So answer is the data which you're going to launch from here, it is anyways going to override this particular data. But we want like, okay, once this flip-flop capture this data properly, once this flip-flop capture the data A properly, after that we should overwrite it. So we are not saying don't overwrite. We are saying overwrite. We are saying overwrite. But after this time, so it's just like in your airport, there is a seat, and that particular seat someone is sitting. We just want like once that person just boarded a plane, then some other person should come and sit on that particular plane, on that particular seat. That's the only difference. We are not saying don't overwrite, but after certain time. Is it clear now? Bhargavi? Kuma Bhargavi, yeah. once timing been set for one data, let's say data A, how come data B may disturb? Because every data will enter from FF1, right? Yes, so you're right. Every data is going to enter from FF1, but the nature of the data can be changed. That means one data can be the rising data, another data can be the falling data. That means the previous data is a 1, now the next one is a 0, and then 0 to 1. So the nature of the data can be different. Because of the nature of the data, the delay can be different. And if the delay is different, and then again we have minimum and the maximum, we don't know which particular data we are talking about. So we have to make the circuit compatible for all type of data, whether it is a 0 to 1, 1 to 0, 1 to 1, 0 to 0. The data should be like it should be properly captured by the other flip-flop. So we are doing this analysis just to make sure, like, okay, this path is independent of data. And that's the reason we are doing the static. That's the reason we are talking about the static timing analysis. That means this path is independent of data. Because the moment the path becomes data dependent and you're going to do the analysis based on that, then you have to do the analysis for each and every data. And that's what you don't want to do it. Is it clear? So guys, just take 1 minute just to understand, like, okay, if everything is clear. I'm just waiting for your questions. So Venkat is asking, data reached within old or setup window will go to the metaservice state, but not replace the previous data, and instead the data will be unknown state. So if you're saying it's not going to replace the previous data, what does that mean? Replace the previous data. So if you want to say matter stable state, yes. Basically, I don't know. So what is the output? Even if it is in a metastable state, can you tell me what's going to be your output data? Anyone have any other question? Okay, sir, if we are using double edge trigger flip-flop, the setup and hold analysis changes. Or if it changes, how to capture setup and hold violation. Okay. Can clock direction and data direction be opposite? Clock direction and data direction. Clock direction, data direction. Okay. So you're saying data direction. What do you mean the data direction? Opposite. So in a flip-flop, input pin is a D pin and output pin is a Q pin. So if you are you're not going to change it in a different way. You're not saying like, okay, from the D, the output will come. Clock direction opposite. So maybe the clock direction opposite. Okay, so I will just discuss a little bit here. When you're saying clock direction opposite, maybe I'm just getting your point, what exactly you're asking. I will just explain you. Just give me a few minutes. Okay, Surya was asking, can you tell how to calculate the setup and hold time at the second and third edge? I think this is what the second edge. This is the third edge, same thing. So for B, B should reach before blue line and the C should reach after this thing. So as such, from the diagram point of view, I'm giving you a basically the analysis from the edge point of view, but whatever holds true here, the same is going to be holds as it is in the next edge, because this flip-flop is going to trigger on a 0, 10, 20, 30, 40, 50. This flip-flop is also going to be triggered 0, 10, 20, 30, 40. So whatever holds good between 0 and the 10, the same holds good between the 10 to 20. Okay, so I think I answered your question. If the clock is from FF1 to FF2 and the data from FF2 to yeah, Aparna. So I got your point. Just give me a couple of minutes. I will explain you that direction related thing. So Venkat, either 0 or 1. In this case, B comes during the setup and hold window, but actually the correct data is A. So what is the output? So in this case, B comes during the setup and hold window. Okay. But actually the correct data is A. So what is the output? I don't know, Venkat, what is the output? That's the reason I'm saying flip-flop don't know what is the output. It can be anything depending upon at which particular stage data is there. So if I'm a tool, I don't know. It can be A, it can be B. I don't know. So I can't give you the guarantee. And that's the reason I just said like, okay, follow these two rules. And then only I can give you the guarantee like, okay, in each and every case, you will get a data A. Okay, so the question was data may be coming from the different sources, for example, other module or from external. In that case, how do we ensure the robust timing between Zakir? Yes, I got your point. Just I will explain you in some time. Surya setup 18, hold is 23 at the second edge. Yes, I think it's the same thing, 18 and 23. What is so setup is basically setup is 18. If you're saying setup is 18, it's like for the second edge before 18 data should reach. But think in this way that which data we are talking about? We are talking about the data which is launched at 10. So for 10, it is 18. That means same 8. For the data which is launched as 20, it is 23. That should reach after 23. What happens if we violate the setup and hold timing? We will discuss that. Surya. Third edge is 28 nanosecond minus is a setup, 33. Yes. But again, Surya, for which data you're talking about? The data which is going to be launched at 20 nanosecond. Again, 28 and 20, it is 8. And 33 is basically with respect to 30. So if you will see everywhere, the relationship is the same. So from the time point of view, maybe you are saying like, okay, it is the 28, 38, 48, but relationship is same. Okay, great. I think now everyone is clear with respect to the setup and hold. Now, there are two questions, two open questions. We'll discuss those two open questions. But before that, I would like to show you this particular part, whatever we understood till now in the reports, because that's something you're going to do. Analysis you're going to do on the report only. Let's see in the report. Okay, I think you can see my window. Great. So it's the same thing, whatever we have did it. Okay, so exit. This is STA. I'm launching that particular part. Whatever we have discussed yesterday, same thing, we are going to do it today. There is a file in this location, which is a sta1.tickle. If you remember yesterday, I have created. I hope you guys also created that thing, source this, and I got it some result. If you remember, this is with respect to the clock 10, and it is a report check. Report checks. So this is with respect to the report check. Now, couple of things. That report check is going to give you the setup results. Remember, by default, tool is going to give you the setup analysis. So report check, and if you remember yesterday we talked about report checks minus path delay, if I'm not wrong. Path underscore path underscore delay, and then it is a max. Yesterday I asked you just to try a couple of commands. How many of you did it? See, this is for the max, okay? So how many of you tried yesterday the commands? So I gave you some commands like max, min, max fall, min fall. How many of you tried it? Okay, I'm just waiting for your answer. How many of you tried it? Only 1% did it. That's all. No one else. So if you are not going to do it, then how it is going to help you? So Surya was facing some problem. I can understand. What about other people? Zakir Hussain, Venkat Reddy, Aparna. I will do that today, sir. I think, see, guys, this workshop is for you guys. Am I right? This is not for we guys. And if you are thinking just a certificate is going to help you in getting a job, no, it's not going to help you a lot. Because when someone is going to ask in an interview, then then and if you're thinking like, okay, if you're not going to do any hands-on, just understanding the concept and then you can do the research work, I think that's not the purpose of the workshop. You can listen the audio or videos from anywhere else. Just a request, please, guys, just do it. This is not a only a conceptual class like where we are going to just discuss a couple of things. I think it's basically just 6 days, 7 days, 10 days. You have to just sit in front of your laptop and you have to just do the things. That's the purpose of this particular workshop. Else, it's a wastage of your time. It's a wastage of everyone's time. Okay. Great. Okay. So if you are not able to do it till now, please, still you have a lot of time. Just do it. And I think I can understand a lot of people are facing issues while installing. Now they are able to install it, but I think if you would have tried seriously, just one day is more than sufficient to try all these things. But okay, not an issue. Just try it today. So I'm going to just show you once again. So yesterday we have discussed this thing, and now let's see what all other commands are there. If I remember correctly, it was help, report, checks. There are these commands. Now I'm just going to give an idea about each and every command and just explain you how it is going to change the things. Report checks, and then minus path delay. Okay, so let's talk about min. So now this one, the above one is for the maximum. And now let's talk about the minimum. So this was for the minimum. Let's do it for max also. Then I will show you the difference. Okay, max, MAX. Now see the output. Okay. Now see, yesterday also we have discussed this thing. When I have asked you like, okay, give me the 4 or 5 differences. The same thing I'm going to ask you right now, but now I'm going to explain you what all those differences, and in the report how you can figure out which is a setup report, which is a hold report. And if we will also discuss like, okay, between the same two path, how you're going to generate the setup and a hold report. We will discuss. Right now, we just mentioned setup, path relay as a max, path relay as a min, and you're getting certain slack. So now let's see from the report point of view. If I am going to give you the two reports, how you will figure out which one is a setup report, which one is a hold report. So in the header section, if it is a minimum, then we are talking about the hold report. Remember how you're going to remember this min? Because between the two flip-flop, we were talking about arrival time. Arrival time supposed to be on a minimum in a setup, sorry, minimum in a hold and maximum in a setup. Remember that 45 minute and 30 minute. 30 minute we took it in a case of a hold, and 45 we took in case of a setup. That means max and minimum. Okay, so this is a one way you can figure out. Second is this portion. Here we are talking about the hold time. Now here in the hold time, it is basically we are saying like, okay, this is my hold time. Now if you will go back here, here it is a max setup, and then here this is a setup time. So these are the two differences right now. Third difference, let me just tell you another difference which can help you to understand Can you see here? This is a 10 clock. So the hour clock time period was 10 nanosecond. In a setup, remember we have discussed we are going to the setup edges is going to be after one clock cycle, and this is basically the one clock cycle. But if you will see in a hold, it is 0 because it is with respect to the same edge. It is with respect to the same, no time period was involved here. Now, just one point I want to highlight here, we are not doing right now the multi-cycle path analysis or the half cycle path analysis. This is something we are doing as a single cycle path analysis. Now you may be thinking, what is this multi-cycle path and a half cycle path? So this is little bit a advanced thing, but just for your reference, maybe you can go back and just do the Google search or read some articles and figure out what is the multi-cycle path. But in a multi-cycle path, right now, our edges were after one cycle. In a multi-cycle, it is going to be after multiple cycles, maybe after 2 cycles, 3 cycles, after 4 cycles. So that is a multi-cycle path. If it is a half cycle path, that means our edges, setup edges is going to be after half cycle. That means one is rising, another may be falling. So if there are two flip-flop, one is a positive trigger, another is a negative trigger, then how the things are going to be happen, that is a half cycle path. But we're not going to discuss that thing right now. We are going to just discuss between the things like, okay, single cycle path. So that is another difference. So this is the third difference you can figure out, like, okay, right now we are talking about the same edge. That means this is basically the hold. You can see now we are talking about the hold. That's the difference which we were talking about, and that's the difference you can see here. Next is, let's try to understand this slack calculation. For the setup, the slack calculation was required minus arrival. So this is the required minus arrival. So 9.93 minus 3.52, the answer is 6.42. This is a setup slack. Now let's try to understand for the hold. Hold was arrival minus required. Arrival minus required. So arrival was 0.41. Okay, this is the data arrival time. Here, if you will see, data arrival time is 0.41 arrival, and it should be greater than the required time. Required time is this. So arrival minus required, and if you will subtract 0.41 minus 0.03, you will get this data, 0.44. So this is basically 0.41 minus this. So now we are talking about 0.44. Now question come, how come this whole time is in negative? Because this whole time is in negative. So there are two more in a hold time and a setup time, there is something known as a negative setup time and negative hold time. Now those things we are going to discuss tomorrow, not today. Just understand right now, there is something known as a negative setup, negative hold. Negative setup. So right now, consider this as a negative hold. So if it is a negative hold, it is a 0.03, 0.0 minus 0.03. So if I'm saying arrival minus required, so simple mathematics, arrival minus 0.03, it is going to be 0.04, 0.44. So this is a hold slack. So What I'm just trying to tell you, when you're going to calculate the slack, then you can see these three numbers and you can figure out whether it is a arrival minus required or required minus arrival. If it is a arrival minus required, that means we are talking about the hold. If you are talking about the required minus arrival, we are talking about the setup. Okay. I think till this point, things are clear. Any question? There are few more differences. I'm going to talk about that particular part now. But till this point, is it everything is clear? So one question is still pending. I know one is a negative setup, negative hold. Once I'm going to give you an idea, then you will get, you will come to know. Second question, I still remember in terms of direction of a clock. I know like what does that mean? We will discuss that particular part. And just apart from that, any other question? So Naveen and other people, don't ask question just like what is the input activity factor. Now, what is this input activity factor? Where it is, you're not talking about anything right now as an input activity factor. Where it is written input activity factor in this report. Is it written somewhere? Okay, yeah. So Naveen, it's not written here. So let's focus here first. See, in STA or in any particular topic VLSI, you can ask thousands of questions. Okay. And those thousands of questions, if I will answer right now, so whatever be our focus, whatever we want to discuss, we will not be able to discuss that particular part. So first focus on this thing. Maybe those points we can discuss some other time. We can discuss that thing. I'm not saying we cannot discuss, but let's focus on this thing. How setup in a whole calculated for unsynchronized clock, say CLK1 and CLK2, Harish, yes. This I'm going to explain at the same time when I'm going to explain you about that reverse direction and all those things. So I will explain you at that particular time. But yes, I have noted that question. Maybe you can remind me later on, but not right now. Why setup slack calculation takes requirement as level and whole calculation? I think Vishnu, this is a question. This is the portion we are discussing from the last 2 days, yesterday also and today also. I will request you just to go back, listen the video once again, and you will come to know like why we are talking about required minus level. Still, like because you have asked a question, I will just try to answer you. Setup is basically you want to reach early. So your requirement is like you should reach by 9. If you're reaching before 9, then it is good. So arrival time is before whatever be the actual time you will take to reach there, and the requirement is a 9. So that's the reason we're talking about in the setup, it is a required minus arrival. Because if it is positive, there is no violation. Now, in case of a hold, you want to reach after certain time. After let's talk about after 10 o'clock. So that means your requirement is after at 10 that you should reach after 10. So first we will calculate actual arrival time and we will see whether your arrival time is after 10 or before 10. If it is after 10, that means no problem. So that means your arrival minus required. I hope this will give you an idea. Yes, this is a good question, Patel. How the setup and hold value of FF are determined. And I seriously want any one of you just tell me how we are going to find out the setup and hold value of flip-flop. Any idea? Then after that, I will explain you. Okay, great. So I think someone said setup and hold, I think, in the library. That's good. But if you're talking about based on the clock edge, okay, so based on the clock edge, Surya, how are you going to find out the setup and hold value? So let me just help you with this. I think that should be a good exercise, or maybe so that would be a good thing for all of you guys. So Zakir saying the report data requires 9.93 data arrival. This according to definition slack. This no. So basically, Zakir, you become confused. So data, so they have already put minus sign extra there. So 9.93 minus 3.52. It's not minus 3.52. Just 9.93 minus 3.52. So for your dot lib, so okay, so let's see. So you have a dot lib here. Let's do it. Just open it. Now just see. Okay, so this is basically this particular flip-flop. Because for this particular flip-flop only, we are trying to calculate the setup time and a hold time. Let's come up here and let's search it here. And this is my cell definition, okay? So this is a .lib file I'm talking about. In the .lib, this is written. Now, from here, let's go a little bit down. So these are leakage power values, which we have discussed the very first day. Then we have the cell footprint, cell leakage power. Then we have flip-flop. See, this is flip-flop. There are two IQ, IQN, negative, and this is those pins. Now we are saying when the CLK is clocked on, the next stage is going to be the D. This is the way the flip-flop is going. You're going to define the flip-flop. Now these are the pins. So these are the basically the pin VGDN. Then VNB, VPB. This is basically for the N bulk. This is for the P bulk. If you remember the very first day we have discussed this thing. Then this is basically VPWR. This is a power pin. Then another pin we have is a clock pin. Then in the clock pin, let's see what is there. In the clock pin, there is a capacitance, there is a clock, it is a clock, it is an input. Then we're talking about the fault transition, internal power. Okay, what else? This is the power section. Okay, then we are talking about the maximum transition. This is the maximum transition you can have on a clock pin. A related ground pin, related power pin. Then it's the timing. So fall constraint, and then we are talking about the related pin. Just one second. This is clock pin. Yeah. And then we are talking about clock versus clock. Related pin, output pin is a Q, related pin is CLK, rise constraint. So these are a couple of constraints. Now let's talk about the D pin. So always remember this, in a D pin, we are going to talk about the relationship between the clock and a D. So the setup is basically clock and a D pin. So in a D pin, capacitance, direction, fall capacitance, internal power. Now let's talk about the timing portion. So in the timing, this is basically the fall constraint. So when the falling is happening, then what is going to happen? Rise constraint. When rise is happening, then what is going to be happen? And what is this? This is basically the timing type. This is a setup rising. So now, what is the setup rising? That means now we are talking about the setup numbers. So setup number is rising. When the clock is rising, then we are talking about the setup rising, because this flip-flop is a rise triggered, uh, positive triggered flip-flop. So setup rising. After that, fall. If at a D pin, the signal is falling, then this is the constraint. If at a D pin, signal is rising, then these are the constraints. So this is which type of constraint? This is a setup constraint. Similarly, if you will go a little bit down, here you will see they are talking about the hold constraint. So here they are talking about the hold rising, hold constraint. Now in this hold constraint, if you will see everywhere, like here, there is a negative hold. There is a negative hold. There is a negative. So these values are negative. And that's the reason tool is not going to calculate anything. Tool is going to calculate itself. Tool is going to do the calculation on the basis of this particular part. Now here it is already written as a negative. That's the reason it is negative there also. So it's written here. That's the reason it is negative hold time there also. And a positive in a hold, sorry, in a setup. Also, if you will see, even in the setup, there are certain negative values. See, this negative values is there. This negative values is there. So that means there may be some cases where you will have a negative setup time also. So now what is remaining? Negative setup and negative hold time. But I think I answered your question from where tool is going to pick this setup and a hold values of a flip-flop. Now, in this case, you can see the setup and hold values has certain metrics. That means these setup and hold values are not a single value. It is in the form of a matrix. And what is that matrix? If you want to understand, see, this is the way we have discussed that day. Like, okay, it is going to be something like that. Let's see. So where is that lookup table? This is the lookup table. See. Now what is written in this lookup table? Variable one, that is a related pin transition. And what is that related pin transition? That is a clock. Because inside the D, it is a related pin was a clock. That means the related pin transition. That means the clock transition. So that means the setup has a dependency over the clock transition. So transition time of a clock at a CLK pin. Second variable is constraint pin transition. What is the constraint pin? D is a constraint pin. That means we are talking about the signal which is present at D pin, the transition of that particular signal. So that means the setup time and the hold time has a dependency over two factors. One is transition time of clock and the transition time of a signal at D pin. So that means if you're going to change the transition time of your D transition time of a signal at a D pin, it is going to change the setup time and the hold time also. Similarly, if you're going to change the transition time of your clock, your setup and a hold time, that is going to change. Is it clear now? So I think this question, a lot of people are asking, like, okay, setup and hold time are decided by the flip-flop paras, which decide the delay of the flip-flop. So these values are dotted with respect to the related pin. Yes, good. Significance of negative hold time, setup time, Venkata, I just mentioned. I'm going to discuss that thing later on. Okay. Now, how the positive negative S trigger flip-flop will affect the setup and hold violation. I think now you got got the answer. Like, okay, it is all negative trigger and positive trigger because in the flip-flop, it is the way it is going to be captured. So someone asked, like, okay, what is going to be happen if my flip-flop is a dual trigger, positive and the negative? So in the library, you will see it will have two tables. Right now it is for setup rising, then it will have the setup falling also. And accordingly, there will be some certain setup time, certain table will be there. And accordingly, there will be certain delays. And accordingly, you will have certain the reports. The reports is going to be changed accordingly. Okay, so doing ST on the synthesis netlist include only cell delay or will it take the estimate net delay? Please explain. Harish, okay. So, okay. So answer is if you will provide the net delay, it will take the net delay. But obviously you will, there is another concept of wire load model. So which I'm not going to discuss right now. But uh, if those models are there, then it will take the estimated net delay also into consideration while you're calculating the timing or the delay value after synthesis. Okay, so Kumar Bhargi, sir, is it possible both the setup and a holds are violated at the same time? Huh. That is okay. So first of all, this question is answer is yes, it is possible. But practically, if it is happening, that means there is a problem in your library. So think in this way: if the setup and hold is violating, so maybe your clock frequency. So think. So let me just draw the diagram and then let me explain you. So if this is the thing. Now here you're saying like okay, setup and hold both is going to be happen or not. So basically you're saying for this particular edge, this is my setup. So this is basically the setup we are talking about. And for this, we have a hold. So this is a hold. So setup and hold. The setup and hold both are violating. I that means these two lines are very close to each other. So question come how can it happen? It can happen if your setup and hold times are huge. Then maybe you can say like okay from here to here this red line is moving in this direction, this is moving in this direction. Or you can also say setup and hold time is same, but the time period, the clock, this time period, or if we will talk in terms of the operating frequency, that operating frequency is something which is very less because as per the library, setup time is going to be fixed for a particular transition, and let's take it is a 2 nanosecond and a 3 nanosecond. So setup is 2, hold is 3. Let's take an example. So that means if your clock time period is 5 nanosecond, both are overlapping with each other. If your clock time period is more than 5 nanosecond, then there is no problem. I'm not talking in terms of a combinational delay right now. I'm just talking from the only these things which you have provided me, the library and the clock frequency. If you have a 10 nanosecond clock time period, no problem. 20, no problem. And I'm not talking about in terms of a delay right now. I'm just talking in terms of the specification, the library which you're using. So both are possible, but in which condition? So either your library is very bad, or maybe you're not using the right set of clock frequency. I hope I answered your question. Is it clear? Okay, somehow my screen again is stuck. So it will be back in a couple of minutes, then I can do something. Okay, I think now I'm back. Yeah. So, last setup and hold. So why hold is independent of the clock period, unlike setup time? Harish, again, so it's independent of the clock period. It's basically in a single cycle. I explained to you, like, okay, we are not going to take consideration of a clock period. But if we are going to talk about the multi-cycle, then maybe you have to take it. And why the setup time has a dependency over the clock time period, I think that's also I gave you an idea, because in the setup time, it's not about basically the setup time, it's about the setup check. So setup check and a hold check. Setup check has a dependency over the clock period because we are talking about after one clock cycle. In a hold check, we are not talking about the after one clock cycle. So that's the reason we are saying it's independent of the clock time period. It's not like setup time and a hold time. Setup time and a hold time has a dependency over only two things: time, that transition time at a clock, transition time of a clock, and transition time of a data at D. Okay, guys. So is it clear? I think this portion, library portion, it should be clear by now. And if you guys have opened this particular library, I ask you guys just to open the .lib and just check it. What is inside that? If you would have done it, I'm sure you would have. Okay, how the values shown in the files are decided. So Surya, it's basically after simulation, library characterization, cell characterization, you can say, these values usually come. I think no questions now. Okay, so now let's take one more, couple of more commands here. So I just want to show you which I was expecting you guys should do it, but report checks minus path delay. Now let's take an example of min. After that, let's take an example of min fall. And then I will show you what is the significance of this particular part. Okay. So now check it. See, so when it was min, it gave you the result of this particular path. In this particular path, You can see this portion, it was everything is a rising side. The moment you said min fall, that means you need a worst. You are going to do the hold analysis when your edges are falling. Fall in the sense you're going to do you want to do the analysis on the falling side. And if you will see, what does that mean, the falling at a Q? At a Q, it should be fall. If at a Q it is a rising or the falling, that is a different thing. Now, if you will say, like, okay, you need a result, you just want to understand what is going to be happen between this and this. So if you remember yesterday, we had already discussed that -2 and minus from. Let's take that particular example also. So this 2, what was that? 2 is a endpoint. Then minus from, and let's see. So this was my falling. Same thing if I will do for the rising. Let's see what is going to be happen for in rise. So now you can see the same report, same start point, end point, 16041473. Here also 16041473. This analysis was with respect to the falling edge, falling at Q. So that's FF1Q we are talking about. Here it is a rising at Q. So it's the same flip-flop, if you will see, but now it is rising. And in another case, it was falling. Now let's see the delay. For falling, it was 0.32. For rising, it was 0.03. Sorry, 0.33. And in that case, it was 0.32. So now you can see for the falling edge, delay was different. For the rising edge, delay was different. Also, let's check other parameter also. Let's check the hold time, library hold time. It is minus 0.05. Library hold time, it is minus 0.04. Why? Because at this particular place, which is a deep in, which is a capture flip-flop, here it is a rising edge, and in previous case, it was a falling edge. That means it is a different. The transition time is different. Now, if you want to see the transition time, there is a command for the transition time also. And that is, if you want to see help report checks. So there is a input field. So if you will see this field, so we are talking about this field. In that particular field, if you will just write slew, you will get the slew. So let's try that particular part also, so that when you're going to try it, at least you will get. So basically, we are talking about this space fields space slew. So now you will see there is some slew related information is here. Now let's try the same thing for rise also, fall also. So it is a fall, and after the fall, there is something. This is basically the fall thing. Okay. So now if you will see at deep in 0.02, so you can see the slew here. And then if you will see here, the slow is 0.04. So 0.04 rising, 0.02 for falling. So I think now you can understand like, okay, your rising and the falling edge both are because of that, your transition time is changing. Transition time is changing. So your whole time has a dependency over transition time. Now you can see here it is 0.004 and here it is 0.05. There it is 0.04. And if you want to check it, you can go back and you can just check in the .lib file also how these things are mapping with each other. Okay, guys. So I think I gave an idea like, okay, how we are going to do the calculation. So now in this whole report, you can see we did the fall rise, sorry, min fall, min rise. Similarly, you can do the analysis for the max rise, max fall. You can also do the analysis using a minus to minus from. You can also do the analysis with respect to the slew, cap, all those things. So if you want to understand like, okay, what is your input transition, what is your output load, on the basis of that also you can do all the these analysis. So this report is basically all about giving you a the circuit information from the delay point of view, from the transition point of view, from the capacitance point of view. So whatever the mathematics you want to do, you can do from here. And all these values, the tools are doing with a certain calculation. And from where that data is coming, that data is coming from the .lib. Because in this particular report, in this particular file, right now we are using only two files. One is a .lib, another is a uh, .v file. Apart from that, we are not using any other file. Okay, so now it's the time to answer your question. So how many of you have questions? Let's see. No questions? So one question. Harish was asking, what is the clock reconversion pessimism that's shown here as a zero in the timing report? So Harish, whatever I uh, explained you, were you able to understand that particular part 100%? If you say yes, then we'll try to understand like, okay, okay, so maximum usable frequency calculation from above analysis. What is this? Which analysis you're talking about? So Patil, I mentioned that's a part of your, the Patil is asking how the setup and hold time in FF are determined. That's what I have mentioned. It's a part of a characterization. So if you're, whenever you're going to draw, whenever you're going to design a flip-flop, the schematic and everything, then it will have certain NMOS, PMOS, then you will give certain inputs, like maybe you have done the PSpice simulation or something, different input values, you will get the different output values, you will get a graph, then you will figure out like, okay, what is the delay, what is the setup time you have to choose, what is the fall time you have to decide. So what will the maximum frequency over which my design can work? Which report suits best to answer this? So if you're talking about the STA, so STA will tell you, so think in this way, basically You will not able to do the ST until unless you will not tell the clock frequency. So once you're going to decide the clock, only then you will get the report. So if I will say you want to find out which clock frequency, that means you're changing everything. You're saying like, okay, uh, I don't know my clock frequency, and you're just asking the tool like, okay, tell me at which particular frequency my design is going to work. I think that's not the approach. So tool is not smart enough to don't know what exactly you want to achieve. So we usually come up with the specification. On the basis of that we do the designing, on the basis of that we do the analysis. And if we are not able to fix the issues, then maybe we have to discuss like, okay, we are going to whether we should change the clock frequency or not. So now in your case, you're saying you have a circuit and you don't have the clock frequency. That's not the way. So if you want to do in that way, you have to do the hand calculation. So guys, any other question? Because we are almost done for the day. Things are sorted now, at least from my side. I'm expecting you guys should try all these commands to help space report check. At least report check should be good for you. Okay, one more thing. Are you able to see this PDF? I think yes. So this is something which I have asked you. Okay, you guys should download this OpenSTA from Google. If not, in your installation directory where you have installed your OpenSTA, there is a doc. So I can show you that particular part. So this is my installation directory. So this is my installation directory. Inside this, there is a doc, doc doc. If you will do ls here, you will see there is a opensta.pdf. So this PDF is the same PDF. And someone was asking yesterday the list of commands. I would say go and just try it here. So it has all these example related thing, what you should do. See, they have mentioned what is inside the example one. They also have certain, from the theory point of view also, like, okay, what are the different things you can set in what particular way. It is written with respect to the default files they have provided, but on the basis of these default files and this flow, you can come up with your flow also. You can also say like, okay, these are the things. And then they have these different commands. So if you want to try, you can try these commands also. So these are report checks related thing. There are the check setup if you want to do it, if you want to do other things. So I think this is a one manual which you guys should have, and you can just try those things. Like, okay, what are the different commands you can try it, and what are the different options you have. So I gave you two ways to do it. One is help space star. It will list down all the commands and all their options. That's the one way. Another way is just go with this 71 page doc, and it will have around 70-80 commands. You can try those commands one by one just to understand. Okay, guys, I think we are good for today. Anyone have any last few questions? Just let me know. Okay, so Firoza ma'am, I'm almost done for the day. So as such for today, there is no slides because I have used yesterday's slide only.
Okay, sir.
So these candidates have to do certain hands-on and now for today. That's the only task they have for today.
Okay, sure, sir. Thank you, sir. So I request all the participants to please complete your hands-on tasks that has been assigned to all of you. This is an humble request to all of the participants. Secondly, we are getting a lot of requests from the participants of other academy for sharing the WhatsApp link. I request you all to please note that there are some limitations regarding the size of a WhatsApp group. We are already having one group for IIT Guwahati, and we requested all the other coordinators to create their own WhatsApp group. If you are not able to have the queries been resolved in the class, so I request all the participants to please share the query with your coordinators. And I request the coordinators to please forward the query in the WhatsApp group where all the coordinators are added along with the expert, so that the query can be forwarded to us. We will resolve the query and we will share back to the coordinator so that the coordinator can convey the same to the participant. So this is a humble request to the participant to please forward the query to the coordinators, and this is also a humble request to the coordinators to please forward the query in the WhatsApp group where you all are added with the expert, so that we can resolve the issue. Because we cannot go for adding all the participants in a single WhatsApp group because of the limitation of the size of the WhatsApp group. Or else all the coordinators are requested to create their individual WhatsApp group, and we can request our expert to join the WhatsApp group. So I request you all to please note the same. We received 2 requests regarding the reopening of the test link. On the first day as well as the day of the MCQ, we already informed that we will not reopen the link. The test will be conducted as per the scheduled timing, and we have given sufficient time. Instead of having a time bound, we have given sufficient time to all the participants to do the MCQ and complete the same. So we will not be reopening the link. I request you all to please note that. The second MCQ will be again on 9th of April. So all of you are requested to please join the MCQ link as per the scheduled date. We are not going to reopen the link or going to conduct any other test for the participants. So thank you all for joining us today. So tomorrow again at 9:30 a.m. we will start the session. I request you all to please end your event. Disconnect from the event. We will end the event in another 2 minutes. Thank you all. Thank you, Aditya sir and Puneet sir.
Thank you, ma'am. Thanks a lot, everyone. Bye-bye.